Have you ever looked up at the night sky, at all those twinkling stars, and wondered, is that all there is? It's a beautiful thought, but what if I told you that everything we can see, every star, every galaxy, every planet makes up less than 5% of the entire universe? The other 95% is a complete mystery. And the biggest part of that mystery, about 27% of the universe, is something scientists call dark matter. So what is this stuff? The truth is, we don't know for sure. The dark matter simply means it doesn't interact with light. It doesn't shine, it doesn't reflect, it doesn't absorb light. It's completely invisible to all of our telescopes. So if we can't see it, how do we even know it's there? The story starts back in the 1930s with an astronomer named Fritz Zwicky. Zwicky was studying a huge group of galaxies called the Coma Cluster. He was measuring how fast the individual galaxies were moving, and what he found was bizarre. These galaxies were zipping around so fast that the gravity from all the visible stars and gas in the cluster should have been strong enough to hold them together. The entire cluster should have just flown apart. It was like watching a merry-go-round spinning so fast that the people on it should be flying off, but somehow they weren't. Zwicky proposed a radical idea. He suggested there must be some kind of invisible mass, some dunkle matter or dark matter, providing the extra gravitational glue needed to hold the cluster together. At the time, his idea was largely ignored. It was just as strange. Decades later, in the 1970s, another astronomer named Vera Rubin was studying individual spiral galaxies, much like our own Milky Way. She was looking at how fast stars orbit the center of their galaxy. Now, basic physics tells us that stars farther away from the dense, bright center should move slower, just like how Pluto orbits the Sun much more slowly than Mercury does. But that's not what Vera Rubin found. She discovered that stars on the outer edges of galaxies were moving just as fast as stars closer to the center. This was mind-boggling. The only way to explain this was if the galaxies were embedded in a massive, invisible halo of, you guessed it, dark matter. The gravity from this dark matter halo was giving those outer stars an extra gravitational kick, keeping their speeds high. It was Vera Rubin's groundbreaking work that finally convinced the scientific community that dark matter wasn't just a weird idea. It was a fundamental component of our universe. Her observations have been confirmed countless times since. We see the effects of dark matter everywhere we look. One of the most stunning pieces of evidence comes from something called gravitational lensing. Einstein's theory of general relativity tells us that massive objects can bend the fabric of spacetime. This means that a huge amount of mass, like a galaxy cluster, can act like a giant cosmic magnifying glass. It can bend the light from objects located far behind it. When we look at these clusters, the light from distant galaxies is often distorted into strange arcs and rings. By measuring how much the light is bent, we can calculate the total mass of the cluster. And every single time, the mass calculated from gravitational lensing is far greater than the mass of all the visible matter we can see. The extra mass comes from dark matter. It's like seeing the imprint of an invisible object on a trampoline. You can't see the object itself, but you can see the effect it has on the fabric around it. So dark matter is real. It's the invisible scaffolding upon which the entire cosmic web is built. The large-scale structure of the universe, with its filaments and voids of galaxies, only makes sense if dark matter was there from the very beginning, clumping together under its own gravity and pulling normal matter along with it. Without dark matter, galaxies as we know them, including our own Milky Way, probably wouldn't have formed. There wouldn't have been enough gravity to pull all the gas and dust together. This brings us to the biggest question in physics today. What is dark matter? We know what it's not. It's not just dark clouds of gas and dust, because we could detect those. It's not black holes or dead stars, because we would have seen their gravitational effects on a smaller scale. It's not any of the particles in the standard model of particle physics, the protons, neutrons, and electrons that make up you and me. It has to be something completely new. The leading candidates for dark matter are hypothetical particles called WIMPs, which stands for weakly interacting massive particles. Massive means they have mass, which is why they have gravity. Weakly interacting means they barely notice normal matter. A billion WIMPs could be passing through your body every second, and you would never feel a thing. They're like ghosts passing through walls without leaving a trace. Scientists around the world are in a race to detect these elusive particles. They've built incredibly sensitive detectors deep underground, shielded from cosmic rays and other background noise. Experiments like the Large Underground Xenon Experiment, or LUX, use huge vats of supercooled liquid xenon. The hope is that, just once in a blue moon, a WIMP will bump into a xenon nucleus, creating a tiny flash of light that the detectors can pick up. So far, we've found nothing. Other scientists are trying a different approach. At places like the Large Hadron Collider at CERN, they're smashing particles together at nearly the speed of light. The idea is that if you smash two normal particles together with enough energy, you might be able to create new, exotic particles, including dark matter particles. If a dark matter particle is produced, it would zip away without being seen, but we could detect it by noticing that some energy and momentum are missing after the collision. It's a bit like seeing a cue ball hit a rack of billiard balls and noticing that one ball mysteriously vanishes, but you can infer it was there by how the other balls scatter. Again, so far, no luck. The search for dark matter is one of the most exciting and frustrating quests in modern science. It's a humbling reminder that the universe we see is just the tip of the cosmic iceberg. There is a vast, dark ocean out there that we are only just beginning to explore. Solving this mystery won't just be about finding a new particle. It could revolutionize our understanding of gravity, the origins of the universe, and our fundamental place within it. Every unanswered question in science is an opportunity for discovery. The story of dark matter is a testament to human curiosity, to our relentless drive to understand the cosmos, even the parts we can't see. The answer is out there, waiting in the darkness. Thank you so much for watching. If you enjoyed this journey into the unknown, be sure to hit that like button and subscribe for more adventures into the mysteries of the universe. See you next time.